Hello everybody, that's my first video after about a year. I didn't record anything because of the war mostly. If you want me to continue recording things, please like this video and subscribe to my channel. And perhaps I'll continue recording something going forward. So today I want to say a few words about the molecule of the year according to the Chemical Engineering News magazine. And this molecule is perfluorocubane, and the idea why its molecule was selected as a molecule of the year is because, of course, because it's beautiful, that's the first thing, but also because by reducing it with one electron, they put this electron inside the cube. So I'll give a little bit of context first. So just, putting something inside the molecular cage is a pretty cool research topic in the recent years, and mostly people deal with putting stuff inside fullerenes. You take something small molecule or an atom and put it inside the fullerene, and this way you can research a single molecule, something that you cannot do by most other methods. Why limit yourself by putting a molecule inside the molecular cage? Why not put a elementary particle inside such cage? But if you take a fullerene and add an electron, it will not go inside, it will stay on the surface delocalized between the double bonds of the fullerene. And the idea of making this cube with fluorines is based on the fact that few fluorines are electronegative atoms, the most electronegative atoms in the periodic table. Electronegative means they attract electrons, and there were some theoretical calculations done in 2004 that showed that if you put an electron on such a molecule, it will be sucked inside it. But it was pretty problematic to synthesize such a cube. Fluorines are pretty big, they repel each other. It's hard to bring all those carbons together. The black things are carbons, of course. This molecule was synthesized in 2022. Now, I don't want to go into a synthesis and into the characterization and the chemistry that the authors did with this molecule. Actually, another channel, a new channel about chemistry did it. I'll give a link in the description below. That's the channel of That Chemist. Check this video there for more details. This is Professor Akiyama. In her group, this molecule was synthesized, and they also put an electron in this molecule. So they reduced it by running electric current inside the frozen matrix, and they identified this reduced anion radical by several spectroscopic methods. This is a theoretical calculations of the spin density, and it shows that the electron is really, most of it is located inside the cube. Formally speaking, it is an electron in a cube. However, you can see that there's some of the electron density, spin density is on those atoms here, so it's not fully in the cube, and it's actually not the same as putting something inside the fullerene, if you know what I mean. So if you put like an atom on a molecule inside the fullerene, it just, it's like runs inside the fullerene, bouncing back and forth, it just cannot get out. But an electron in this perfluorocubane is more like, it's just how things are. It's not like it cannot escape from there. Take any molecule and look at any spin density or electron density on the molecule on some of the orbital and say, well, you trapped an electron on those orbitals. But it just looks aesthetically great, right? Now, this molecule is not stable, right? I said it just falls apart after being reduced right away because, the strain here in between the carbon-carbon atoms is just huge. I would say put this perfluorocubane in a larger cage. Probably it will not fit fullerene, but maybe a larger carbon cage, and then try to reduce it inside the cage. Maybe then it will stay stable, and you can study this in more detail. Anyway, that's the molecule of the year. Not much more to say about it. Check the video of That Chemist. He shows beautiful cube crystals, and support Ukraine, of course. Thanks a lot and have a great day.